Okay, so we've done all this work in rearranging logarithms and rearranging exponential equations and doing all these things using the power rule and the quotient rule and the power and the product rule and all that stuff. And so now it's time to put it to use, okay? We're going to solve equations involving exponents and logarithms. This video is going to focus mainly on some of the simpler exponential equations and logarithmic equations, okay? If you want to see more advanced stuff, you probably want to go to part 2. But in general, the rule goes like this. If you have a logarithm in your equation, like you do in this first example, probably going to end up using exponents in order to solve it. I'm going to have to turn it into an exponential equation. If I have an exponent in the beginning, right here, I'm probably going to use a logarithm because they're inverses of each other. And that's how I solve for like an exponent, as I use a logarithm. Okay? Also, remember, anytime you get an equation that looks like this, if I can put something into this format, where I had like maybe, let's say, 3 to the log base 3 of x, that 3 log base 3 would cancel out, basically, and I end up with an x. Or I could write it in this format. If I have log of base of a number of that number to the x power, the log base a of a basically cancels itself out and you drop the x in. That's just an x. Okay? That's going to help us out a lot in this. Sometimes the problems are easy. Okay, so first example, log base 3 of x, or 3, log, let me start that again, natural log of 3 minus natural log of x is equal to 0. Well, in this case, if I just add the natural log of x to both sides, I see that I end up with the natural log of 3 is equal to the natural log of x. And there's only one way that this can be true. That's if 3 and x are the same value. X must equal 3. So that one's pretty straightforward. But in this one, we got to go a little bit further. See, I say e to the x is equal to 7. E to what power gives me 7? Well, since I have an exponent involved, and I see it's e, by the way, that means I'm going to use the natural log to solve this. You see, if I took the natural log of both sides, which I can do that. What I know is this, the natural log of e, well, it's assumed the natural log is base e, and so it looks a lot like this, doesn't it? The natural log of e cancels out, I'm left with x on the left. X must be the natural log of 7. Now there's an exact answer. In my math class, I would prefer you to write that. I would like to see natural log of 7. But if we're going to do it on the calculator, we can always go like this and say natural log of 7. It's about 1.945, 1.946. So if we put it in decimal format, we could always say this. Notice the squiggly sign, right? That means approximately. X is approximately 1.946. It's actually a decimal. Next problem. Log base 10 of x is equal to negative 1. Now this involves a logarithm, which means I need to probably use an exponent in order to solve for it. Whatever number I see here in the base, if that's a 10, that means the first step that I'm going to use to solve this problem is I'm going to take 10 and make that the base of an exponent on each side. See, I can say 10 to this power then is the same thing as 10 to the negative 1 power. And now I have an equation, and look at that, 10 to the log base 10 of x. These things go away, and I'm left with just an x on the left. X must be 10 to the negative first power, which is the same thing as 1/10. Log base 10 of x. Now, one easy way to check it, because this is log base 10, that's the same thing as the log button on your calculator. The log of 1/10, is it equal to negative 1? Log of 1/10 is equal to negative 1. So I know I got that problem correct. One more problem, and then I'll go on to part 2. Okay? Now what happens if we have this? Notice that this 2 is the only thing being raised to the exponent of x. My first step, no matter how complicated the problem gets, my first step is to get this thing by itself, this chunk of information by itself, the thing with the exponent. So the first thing I have to do in this problem is divide both sides by 3. 3 times this thing is equal to 12. So that means that 2 to the x must be equal to 4. 2 to what power gives me 4? Well, this one I might be able to answer in my head, but let me show you a different way to do it, okay? I might know that this is a 2. But it's all right. Let's go through and let's keep working this problem. 2 to what power gives me an x? If I say then that I want to take the log base 2 of both sides, You see, this method is going to work for more complicated numbers when it's not nice and easy. Like what if that was a 5? That would be a more difficult problem, right? Over on the left, I see that I have log base 2 of 2 to the power. That goes away. I'm left with x equals. X is equal to log base 2 of 4. Now I can use the change of base formula to say, well then, if I want to evaluate that, that's the same thing as the common log of 4 over the common log of 2. And that's something I can put in my calculator. That would be approximately, let's check it out, log of 4 in parentheses divided by log 2 in parentheses. Oh, it's 2. I don't even have to do approximately. I end up with an answer that I expected, right? 2 squared is equal to 4. So there we go. If this makes sense, then maybe you're ready to advance to a little bit more difficult problems. That would be the video part 2.